If you don't like using AI to drop your rounds for you, and if you still can't figure out how to range in your mortars, this is the video for you. I'm going to go further in depth than my last video on how to find your distance and how to find the degree you're trying to look in terms of the compass and all that. And I'm going to do all of this in the mortar course within the training scenario in the game. And the first one, when you're shooting at the island, I had already pre-marked that one out. I had the range and degree written down, so I don't talk through that one. That's just me doing it as fast as I can with already knowing the objective. But the second objective is where I get into the nitty-gritty and all that you need to know about ranging and getting your gauge and azimuth reading. But yeah, I'm just going to throw it to the video. I hope you enjoy and I hope you learned something new.
Sergeant, glad you could make it. Let's walk you through this real quick. Give you an overview of the basics. Go ahead and man that mortar over there. First off, we want to switch from using HE ammunition. I got orders to put holes in the runway later, and you know, we'll want to save some for the Russians too. Now, before we get ahead of ourselves, we need a target. Let's start with the little island out yonder. Find it on your map. To score a hit, we've got to adjust our fire. Okay, next, we'll want to estimate how far away our target is. Measure the distance using your protractor or the scale at the bottom of your map. Then, as you did before, set your calculation on the fire controls. All good? Take an 81mm round out of the ammo box beside me. And finally, drop it into the mortar bag. Once those fins are in, obviously, as we're dealing with indirect fire, we can't see to adjust our aim. That's where forward observers come in. Ordinarily, I'd radio shot, but you get the gist. Let's wait for confirmation.
Atlas Green 1, Atlas Green 2, shot on target, out.
Bomb diggity, that's how we do it. Well done, Sergeant. Let's shake things up a bit. Do what you did again. Only this time, we'll try and land around on the lighthouse across the bay, using just your map. Open it now, and yeah, take a look.
So using this example in the training scenario for the mortars, we have to hit the lighthouse from this position up here. So what I would recommend doing to find the angle that you need to shoot at is to zoom in as much as you can on your position. Thankfully, it's already marked. Getting your exact position is probably the most important part. And go all the way down here and go past the lighthouse. About here. So that way when you bring up the protractor and you put it on your location, you can get both the radians and the degrees for where you're aiming. So when it comes to the outer scale, the radians, these on the outside here, they're at increments of 100. So the big marks are 100, 200, 300, 400. So that means these little marks are in increments of 20. So it'd be 20, 40, 60, 80, 100. So it says 2, 4, 6, 8, 10, 12, 14, but you're really thinking 200, 400, 600, 800, 1,000, 1,200, 1,400, so on and so forth. If I just did it to the lighthouse, I'd only be able to use the degrees, which is this inner scale here. And in my experience, the radians are a lot easier and more accurate, it seems, for me. I don't know if it's personal preference or what, but I use radians. So down here, this is 2,700 and 2040, like 38 or 39 from our position. Now, with my mortar actually put in line with where I'm trying to shoot, what I'm going to do is take away my protractor and show you guys how you can find the distance from this point to this point. So there's a couple different ways you could find the distance from your position to where you're shooting. You could either count the number of X's and Y's here and use this many meters and this many meters to put those numbers into the Pythagorean theorem and find the length of this here. Pythagorean's theorem is a squared, which is this left side, plus b squared equals c squared. So then you would need to put this number, square it, put this number, square it, add those two together, then you find the square root of it, and that will be c, which will be this. Okay, so since I'm using 21021, this grid square, and counting this bottom left corner, I'm going to go down all the way to where the lighthouse lands in the X, but keeping in this Y. Since it's in this grid square, I'm going to range for this one, which is 0, 1, 2. So 0, 2, 1 minus 0, 1, 2 is 9. That is 900 meters. So I'm at 900 here. I'm going to go maybe about another... I'm going to go another 45 meters because this lighthouse isn't quite in the middle. It's still a little bit up towards the top, so 945 meters. So with this leg of the triangle being 945 meters, I'm going to multiply 945 by 945 and keep that number handy for once I figure out this leg of it. So what I'm going to do is I'm going to find the Y that my position falls in, line it up with where that lighthouse is, and this square is where I'm going to take this reading from to find this leg of the triangle. So 0, 1, 0 to 0, 1, 4. So 1, 2, 3, 4. And this is just over halfway through this square, so I'm going to do 60 more. So I'm going to do 460 meters times 460. And I'm going to add that number to the previous number I just got. And then I am going to find the square root of this number here. And the square root of those two legs added together is 1,051 meters. So if you look here, this is 1,051 meters long on this line. We solved for this and this to get us this. Now, just to show you the second way you can find the range, I'm going to pull out the protractor here and wiggle it around and find out where it lines up with that line. So to get it to line up with that line, you can use these crosshairs in the center to get it to perfectly line up with the line that you drew. And right there seems about good. Now, what you want to do is put your position in the crotch of this along this triangle here. That's still not lined up perfectly, but it'll work. I would line up the inside of this 0 directly with your position. So, like before, each one of these is 100 meters. So that's outside of 1,000. So it's 1,000 and a little bit more. So what we can do is make a note of where this ends and bring your 9 marker right to it. Because now you can use this 9 marker as a 0 and just go 10, 20, 30, 40, 50. But we'll range it in for 150 because I trust my Pythagorean theorem more than I trust my placing of the protractor. So the next thing I have to do is use the number that I found by using my Pythagorean theorem, which was 1,050 meters, and range that in with the gauge on the right using the gauge on the left. So 1420 is 1,000 meters. So right now we're ranged in at exactly 1,000 meters. So I'm going to show you guys the equation or system to find out how much distance a single mil accounts for. And you're going to have to do this calculation every time you switch rings because it changes the number of mils to the number of meters every time. A good thing to do would be to do all these calculations for large numbers and write them down in a notebook that you can have nearby or put them in the notes section of your phone. So let's say you have to switch to 2 rings fast. You can just look at that reference sheet and see what 2 rings 100 meters difference is. On the right side, you have your range, and it is represented by meters and mils. It helps you get to the round number, but it doesn't really help you with your adjustments. What I would recommend would be using an equation to figure out how much a mil represents in terms of meters and adjusting accurately and specifically with those mils rather than just guesstimating with your range. So I'm at 1,050 meters for that lighthouse, and 1,050 meters is in between 1,420 mils and 1,402. Using those two numbers, I can find how much a mil is in terms of meters. So what I'm going to do is I'm going to take the mils of the higher number mils, so 1,420, subtracted by 1,402. So that's 18 mils per 100 meters. So then you can go 100 divided by 18. Every mil accounts for 5.5. So if I need to go 50 meters more from 1,420, I would need to adjust 9.09 mils. So we'll just say 9. And I did that by dividing 50 by 5.5, which is how much every mil represents. So 50 divided by 5.5 is 9. So I need to go 9 mils over 1,000 meters at 1,420 mils. So it gets tricky when you get to this point because going up in a number is going closer in range and going down in a number is going further in range. So when I took 50, divided it by 5.5 and got 9, I need to subtract 9 from 1,420 in order to reach further out rather than bring it in. If I add the 9, I'm going to be doing my calculation in the wrong direction and bringing it closer to me. So 1,420 minus 9 is 1,411. So on the left side, I'm going to adjust 1,411 and at 2,739 mils or 154.1 degrees on the compass, and at 1,411 mils for my distance or 79.4 degrees, I should be landing this practice round directly on that lighthouse. So what I'm going to do is back out, hope that this is adjusted correctly, fire, and wait for my forward observer to let me know if this round hits.
Atlas Green 1 to Atlas Green 2. Shot on target. Out.
You heard the man. Good going. All right, let's call it there. It does seem you got a head for numbers, Sergeant. So, try not to lose it.
And that's how you can find a target that is not within sight. The most effective thing is having a good forward observer to watch your targets land and to report to you where they land, if they land where they're supposed to be, and communicate with you to get it on the right spot. Now, there is a way to use AI to do this, and it's a lot easier, but it's also a little bit more difficult in its own way. And it's also kind of cheesy because you could drop rounds directly where you want to, super easy. And I prefer not to do it. I'd prefer a team of real players as a mortar crew rather than AI players because it's just a little bit cheesy and overpowered at this point. But some people use the meta and don't give a crap about anybody else, so can't do much there. So to wrap it all up, first thing you're going to want to do is find your exact location. Since this is marked on the map for when you're doing the exercise, it's a lot easier, so you don't need to do that step. And if you do not know how to find your exact location, I do have a video up, and I'm planning on making another one to get an even more accurate representation of where you are, because the last one was just kind of showing the process of it, not actually doing it. But either way, the first thing you want to do is find your exact location. Second thing you want to do is find the exact location of the target you're shooting at, and that could literally be a difference between here and here, so it's really important to know exactly where you're shooting. Third step is to draw a line from your exact position all the way to and past the position you're shooting at. And then third step is to use your protractor, put it on your location exactly to find the azimuth reading and radian reading of where you're shooting. The azimuth reading will get you close, the radians will get you even closer. And once you have your degree figured out and where you're aiming, you then can close the protractor, count the number of squares on both of these legs of this triangle here, put them to the power of 2, add them together, find the square root of that, and that will equal this length here. Or you can bring out your protractor, use this scale on the inside here, and measure how far it is from your target. So if you really trust your math skills, you can use the Pythagorean theorem to find out the length of this hypotenuse here and do it that way. But really keep in mind of your positioning in the squares, as the bottom left corner is going to be 0, and anything out from that is going to be more meters you're going to need to account for. So if my position was in the center of this square, I would start my counting in the center of the square. And same goes for your target location. This is about 45 meters south of the actual line where 0, 1, 2 is marked. So this would be 0, 1, 1. That's about 75 meters up from 0, 1, 1. So account for that when you're doing your Y calculation. And same with your X calculation. This is just over 50, so I did 65, or I forget what it was exactly. So from 0, 1, 4, it's 65 meters past 0, 1, 4 before it's 0, 1, 5. So make sure you account for those small details like that. But yeah, hopefully this teaches you everything you need to know to get out there and start dropping rounds, because there needs to be less people using AI and more real players actually out there using the mortars and communicating with their team and doing a group effort rather than just using AI players to drop rounds. But yeah, if you enjoyed the video, please like, subscribe, leave a comment. I can go more in detail. If you have any other questions, I can make another video on those. I do have some videos coming out. I had some miscellaneous videos premiere, so if you want to go see some funny moments in Counter-Strike, or if you want to watch the first episode of COD 2, go ahead and do that. But if not, that's completely fine. I'm going to keep working on this Arma series while my other things are that are scheduled start coming out. So there's going to be a decent amount of content coming in the future here, and I've got more stuff I'm working on outside of Arma and a lot more that I'm working on inside of Arma. So yeah, stick around, and until the next one, peace!